Hello, and welcome to Module 11.5, Solving Quadratic Equations by Completing the Square. Our objective for today is that I can solve quadratic equations by using completing the square. So what is the purpose of this? Completing the square is going to create a perfect square trinomial by adding b over 2, the quantity squared, to x squared plus bx. Now, keys to know for this. Number one, to complete the square, we need an a term of 1. So it needs to be 1x squared, or just x squared by itself. Secondly, you're going to go through this process, and what you're going to end up getting is something like, x minus 5 squared, or x plus 2 squared, right? That's what a perfect square trinomial looks like in its factored form. So let's walk through the process and see what it looks like in its distributed form. So what we're going to do, we are going to take our b value, which is negative 16, and we divide it by 2, and then we square it. So we're finding what is this divided by 2, because if you remember, a perfect square trinomial is going to be one thing squared plus 2 times x times y plus something else squared, right? So by dividing by 2, we're taking that x term, we're dividing by 2, and then we're squaring. We're trying to find what's happening here. All right, so negative 16 divided by 2 is negative 8. Negative 8 squared is 64. So we factor this, and we get x squared minus 16x plus 64. So that's our perfect square trinomial, right? First term and last term are both perfect squares. Our middle term is 2 times the square root of each of them. And then we factor it to x minus 8, the quantity squared. Here's a hint when you're doing completing the square. This value goes right there, just like it is. Okay? So let's take a look at letter B. We're going to start, we have 20x, so we do 20 over 2, the quantity squared. 20 divided by 2 is 10 squared, which is 100. X squared plus 20x plus 100. So what are my factors of 100 that add up to 20? X plus 10 x plus 10. 10 plus 10 is 20. So it's x plus 10, the quantity squared. Letter C, we have x squared plus 6x plus c. So we take 6, divide it by 2, and square it, which is 3 squared, which is 9. So we've got x squared plus 6x plus 9, and its factored form is x plus 3, the quantity squared. Now, I would like you to do D, E, and F on your own, and then check your work against mine. So letter D, this is going to be a weird one because we have an odd number. So we have negative 7 over 2, the quantity squared, which when we do square that, or if we did it as a decimal, it's negative 3.5 squared. And when we square that, we get 12.25. So this is okay. It's going to be a decimal or a fractional value that we have as part of our factored form. That's okay. It's just what you're going to have to work with on this. So we go ahead and we write that in. So it's x squared minus 7x plus 12.25. And when we factor that, it's x minus 3.5 squared. Or if you wrote x minus 7 halves, the quantity squared, that would be acceptable as well. All right, letter E. We're going to take 22. We divide it by 2, and we square it. So that's 11 squared, which is 121. So x squared plus 22x plus 121. And then when we factor that, it's x plus 11, the quantity squared. Letter F. Take negative 14, we divide it by 2, and we square it. That's negative 7, the quantity squared, which is 49. So then we have x squared minus 14x, and then plus 49, our perfect square. And then when we factor it, it's x minus 7, the quantity squared. So example 3 is to solve an equation by completing the square. To solve an equation, first you need to subtract the constant from both sides so that it's just an x squared term and an x term. And then you're going to complete the square by adding b over 2, the quantity squared, to both sides of the equation. And the equation must have an a term of 1. So let's look at letter A. We have an a term of 1, so our first criteria is met. Next, we need to subtract 16 from both sides. We get x squared minus 14x equals negative 16. We complete the square. So we do negative 14 over 2, the quantity squared, and we get negative 7 squared, which is 49. So we add 49 to both sides, right? Because properties of equality, what we do to one side of the equation, we have to do to the other side to maintain its relationship. So if we add 49 on the left, we're going to add 49 on the right. Now we're able to factor the left side. So we have x minus 7, the quantity squared, is equal to 49 plus negative 16 is 33. I have a square root on one side that's isolated, and I have nothing else on the right other than a constant. So I'm going to take my square root step. And so I get that x minus 7 is equal to plus or minus 5.74 when we round it, which then we split into two equations. X minus 7 equals 5.74. X minus 7 equals negative 5.74. And last step, we add 7 to both sides of both equations. X is going to equal 12.74. We add 7 to both sides. X is going to equal 1.26. Those are your two solutions. All right. Now, letter B, we are going to subtract 15 from both sides. And we get x squared plus 9x equals negative 15. We go through the whole process again. We've got 9 over 2 squared. So that's going to be plus 20.5, 20.25. And when we do that, and we factor it, we have x plus 4.5 squared is going to be equal to 20.25 plus a negative 15 is 5.25. We're going to take the square root of both sides. We got x plus 4.5 is equal to plus or minus 2.29. We're rounding to the hundredths place there. If you round to the tenths or hundredths place, either would be acceptable. So we have x plus 4.5 equals 2.29. X minus 4.5 equals 2.29. And then we subtract 4.5. Actually, sorry, that was plus 4.5 equals negative 2.29. That's the correct work. We subtract 4.5 on both sides of both equations. We get that x is equal to negative 2.21. We subtract 4.5 from both sides. X is equal to negative 6.79. All right, letter C is one of those cases where I said we need to have a constant of 4, or sorry, not a constant, a coefficient of 1 on my x squared term, and I don't have that here. I have a negative 4. So I'm going to start by dividing every single piece by negative 4. Every single piece gets divided by negative 4, and I get x squared minus 8x plus 18 is equal to 0. So now we can restart with our first steps. We subtract 18 from both sides, and we get x squared minus 8x equals negative 18. And when we look at this, we go to complete the square. So we're going to do negative 8 over 2, the quantity squared, which gives us negative 4 squared, which is 16. So we add 16 to both sides. We get x squared minus, well, actually, we'll factor that right away. We get x minus 4, the quantity squared, is equal to negative 2. Now, when we go to take this square root, can I take this square root? The answer is no, because you can't take the square root of a negative number. So this is no solution, which is possible. There are no solutions. And if we look at the structure of this, our C value, right, this says we're going to be moving down 72 from our origin, and we are opening down with a negative 4x squared. So that means this is opening down and it's shifted down. There is no x-intercept for this equation. So it's never going to cross the x-axis. So therefore, we cannot solve it by any method. And this is just a way that completing the square shows no solution if we have that negative value when we go to take a square root. All right, on the next page, there are 3 problems for you to try. Check your work against mine. Letter D, we start by subtracting 14 from both sides. We get x squared minus 10x is equal to negative 9. We do negative 10 over 2, quantity squared. So that's negative 5 squared, which is plus 25. Do that on both sides. And then we're going to factor right away. X minus 5 squared is equal to 25 plus negative 9 is 16. Next step, square root both sides. X minus 5 equals plus or minus 4. Split it into 2 pieces. X minus 5 equals 4. X minus 5 equals negative 4. Add 5 to both sides. X is equal to 9. Add 5 to both sides. X is equal to 1. And this is one we could have done with factoring, but hey, here's completing the square method. You can learn with it. Letter E, we start by subtracting 3 from both sides. We got x squared minus 8x is equal to negative 5. We do negative 8 over 2 squared. So negative 8 over 2 is negative 4. Negative 4 squared is 16. And then we go ahead and factor. We've got x minus 4, the quantity squared, is equal to 11. We're going to get an irrational root here, so we take the square root of both sides. We get x minus 4 is equal to plus or minus. We're going to approximate it as 3.32. And we then split into our 2 equations. X minus 4 equals 3.32. X minus 4 equals negative 3.32. And we add 4 on both sides of both equations. We get x equals 7.32. We add 4 to both sides of the second one. we get x equals 0.68. Our last one, letter F, we need to start by dividing everything by 3, including the 0. It's important to remember to show that step. That way you remember that you're going to be dividing by 3 there on everything. Even if it's not a 0 on the other side, that habit is good for you. All right, so we get x squared minus 4x minus 5 equals 0. All right, so we're going to now add 5 to both sides. We get x minus 4x equals 5. Our completing the square process, negative 4 over 2, the quantity squared. So that's negative 2 squared, which is 4. So we're adding 4 to both sides. Now that we have our perfect square trinomial, we have x minus 2, the quantity squared, as its factored form. 5 plus 4 is 9. When we take the square root of that, that's going to be a clean square root for us. We have x minus 2 equals plus or minus 3, that we can then split. X minus 2 equals 3, x minus 2 equals negative 3. Add 2 to both sides, x equals 5. Add 2 to both sides, x equals negative 1. All right, so now you're probably saying, well, why do I need to go through this process if I could come up with factors of negative 5 that add up to negative 4, or I could come up with factors of 16, or sorry, of 3 that add up to negative 8. Like I can do these things. I can factor these. Why do I need to go about completing the square? Well, completing the square helps us find vertex method. It finds the vertex form of an equation so we can get to pieces on a graph a little easier without having to calculate everything. We can see a little bit of what happens to our vertex just by manipulating the problem. So the equation y equals x minus h, the quantity squared, plus k represents a parabola with a vertex at hk, right? We've already worked on this in a previous module, or earlier in this module, actually. So we've worked with this. We've seen how h is going to tell us how much our vertex moves left to right. K tells us how much we're moving up and down. And so we can use completing the square to take a quadratic function in the form y equals ax or x squared plus bx plus c, and we can make it into vertex form. So we can see and manipulate how we are affecting our our graph. So let's walk the process and figure it out. What we're going to be looking for is our axis of symmetry, our extrema, and our zeros. So what do we have? The first thing that we're going to do in this process is we are going to add 5 to both sides, right? Where you got y plus 5 equals x squared plus 2x, right? We're going to keep it the exact same that we've done already, except I'm going to move this over a little bit so we just have a little bit of room to add something there. Okay, now we're going to complete the square. Remember, how do I complete the square? I take my b value, divide it by 2, and we square it. So 2 divided by 2 is 1 squared. 1 squared is 1. So we're going to add 1 to both sides of our equation. Okay, so now when we do that, we have y plus 6 on the left, and we have x squared plus 2x plus 1 on the right. We factor the right side. We have y plus 6 is equal to x plus 1, the quantity squared. Now you see where I'm going with this? You'd go and subtract 6 from both sides of the equation. You get y equals x plus 1 squared minus 6. And boom, we're in vertex form. So what do I know? What can I figure out? Well, my axis of symmetry goes through my x-coordinate of the vertex, right? My axis of symmetry is going through x equals negative 1. What is my vertex? We're shifting to the left 1, so we're at negative 1, and we're shifting down 6, so it's negative 6. Negative 1, negative 6 is my vertex. What are my zeros? What can I do to find my zeros? Well, I can substitute 0 for y, because that's what a 0 is, and we want to know x plus 1, the quantity squared, minus 6. Or truthfully, you just go back to this step right here, and you substitute in 0 for y, and so y goes away, and you're left with that positive 6 there. So we have 6 is equal to x plus 1 squared. So we split that into our two pieces. Oh no, we take our square root first. Getting ahead of myself. Square root of both sides. Square root of 6 is plus or minus 2.45 is equal to x plus 1, which then we can split into two pieces. 2.45 equals x plus 1. Negative 2.45 equals x plus 1. Subtract 1. 1.45 equals x. Subtract 1. Negative 3.45 equals x. And that's your two solutions. So we have our extrema, we have our solutions, we have our axis of symmetry, we have our vertex. So we're shifting down and to the left, but we're opening up. So we have two solutions. All right, letter B. We're going to take a look at this one. Our first step that we're going to do, we are still going to add 42 to both sides because we're going to get that part isolated. So we add 42. And we get y plus 42 is equal to negative 2x squared plus 20x. Now, we need to get rid of that a term. But I don't want to divide it because then that gets messy on the left side with the y plus 42, and we got to divide it by 2. How about we look at it knowing some of the rules we've worked with of what if we were to take out a greatest common factor here? We take out a GCF on the right. So now we have y plus 42 is equal to negative 2 times x squared minus 10x. Oh, this is a possibility now. Okay, so we've got x squared minus 10x. So now I need to complete the square with minus 10. So negative 10 over 2 squared. Negative 10 over 2 is negative 5 squared. So we're adding 25 there. But what do we add on the other side? Think about it. This still applies to that 25. So what are we going to add on the right side? We're going to add negative 50 because 25 times negative 2 is negative 50. So our next step here, we are going to write this. So y, 42 plus negative 50 is y minus 8 is going to be equal to negative 2 times x minus 5, the quantity squared. And my final step is we add 8 to both sides. We get y equals negative 2 times x minus 5 squared plus 8. And that's what we did at the tail end of the first part of Module 11. We have a vertex form where we are shifting it to the right 5, up 8, and we are stretching it by 2, and we're reflecting it across the x-axis. So all of our transformations are happening on this particular equation. So let's find what is my vertex first. So vertex, the ordered pair is going to be at 5, 8. which means my axis of symmetry is x equals 5. And now if I want to find my zeros, we substitute in 0 in, and I'm going to highlight it for you. We're going to substitute in 0 in this step here just because it saves us a step. So we have negative 8 is equal to negative 2 times x minus 5 squared. Obviously, first step, we have parentheses there. I want to divide by negative 2, right? Because the multiplication happens outside of the squaring, so we need to get rid of that multiplication first. So negative 8 divided by negative 2 is 4, and that's equal to x minus 5, the quantity squared. Square root of both sides. We got 2 equals x minus 5 plus or minus 2. And so if we split our two pieces, we've got 2 equals x minus 5. Add 5 to both sides. 7 equals x. Or if we go the other way, we've got negative 2 equals x minus 5. Add 5. Negative 3 equals x. Positive 3 equals x. There we go. Because it's negative 2 plus 5. Okay. All right, you're going to take a look at C and D on your own and check your work against mine. So letter C, back to a base problem. So we're going to start off by subtracting 15 from both sides. And we get y minus 15 equals x squared minus 8x. And when we do negative 8 over 2, the quantity squared, that's negative 4 over 2, which is plus 16. So we have y plus 1 is equal to x minus 4, the quantity squared. And if we were to rewrite that, we subtract 1 from both sides, y equals x minus 4 squared minus 1. So what do I know? My vertex is going to be at positive 4, negative 1. So we're going to move 4 to the right, and we're going to move down 1. All right. My axis of symmetry is going to be x equals x coordinate of my vertex, x equals 4. And now I'm going to take that green step. I'm going to do the y plus 1. And so we're going to say 0 plus 1 is equal to x minus 4 squared. So 1 is equal to x minus 4 squared. We take the square root of both sides. Square root of 1 is plus or minus 1 equals x minus 4. And then we have, and it didn't write, plus or minus 1. So now we have 1 equals x minus 4. Add 4. 5 equals x. 1, negative 1 equals x minus 4. Add 4. 3 equals x. So your two solutions are at 5 and 3. We have a graph opening up, and it's moving down and to the right. All right, letter D, we start by subtracting 32 from both sides. We get y minus 32 is equal to negative x squared plus 14x. And our first step, we need to factor out that GCF. We need to get rid of that extra piece. So we have y minus 32 equals negative 1 times x squared minus 14x. And now we go about our process. So negative 14 over 2 squared would be negative 7 squared. So when we go ahead and add that, so that's going to be plus 49 there, but it's times the negative 1, so it's minus 49 on the left side. Now what do we do? Well, negative 32 minus 49 is y minus 81 is equal to negative 1, or just negative, x minus 7, the quantity squared. And our final step is going to be to add 81 to both sides. And we get y is equal to negative x minus 7 squared plus 81. So what is my vertex on this? Kind of ridiculous. You wouldn't want to be graphing this. My vertex is going to be at 781. So 7 to the right, 81 up. My axis of symmetry is at x equals 7. And then if we were to substitute in 0 for y, we get negative 81. So we get 0 minus 81 equals negative 1 x minus 7 squared. And when we work that, we have negative 81 equals negative 1 x minus 7 squared. Divide both sides by negative 1, we get 81 equals x minus 7 squared. We take the square root of both sides. Plus or minus 9 equals x minus 7. And so we have 9 equals x minus 7. So we add 7. And we get 16 equals x. We have negative 9 equals x minus 7. Add 7. Negative 2 equals x. So our solutions are 16 and negative 2. That brings us to the end of the notes for completing the square. Again, this is another method that will, number one, always work with any quadratic that has a solution. You will always be able to complete the square. Secondly, it does allow you to get it into vertex form that you can then manipulate and see some of these key factors of the graph a little bit more easily than you would necessarily be able to with a standard form quadratic equation. So that's the end of the notes. If you have any questions, please bring them to class. Otherwise, I hope you have a great day.